Welcome back, learners! In this video, we're going to discuss the following basic derivative rules. To all our viewers, please do not forget to click subscribe to learn more from our future videos. Thank you! There are different notations that we use for derivatives. If we are given y in x terms, say for example, y is equal to 3x squared plus 1, then the notations that we can use for derivatives of y with respect to x are y prime or the dy over dx. And if we are given the function of x, f of x, is equal to 3x squared plus 1, then we can write the derivative as f prime of x. Let's now proceed to our first derivative rule, which we call the derivative of a constant function. The derivative of a constant function is always 0. If we have a y equal to k, where k is any constant, then y prime is equal to 0. So, for our examples here, y is equal to 7, therefore, y prime is equal to 0. Y is equal to negative 12, therefore, y prime or the derivative of y with respect to x is equal to 0. And the last one, y is equal to pi. Remember, pi is a mathematical constant, is still a constant. Then y prime is still equal to 0. Derivative rule number 2 is called the power rule. It says that if y is equal to x raised to n, then y prime is equal to n x raised to n minus 1. Let's do the following examples. So for the first one, we have y prime is equal to the n here, which is the power, is 4. So we bring that down as multiplier. And then x is still the base raised to, now the new exponent, 4 less 1, that will be 4 minus 1. So we have 4x raised to 3. And that is our derivative for y is equal to x raised to 4. For the next one, we have y is equal to negative 3, x raised to negative 3 minus 1. Therefore, we have negative 3, x raised to negative 4. And if we want to simplify this with positive exponent, therefore we have negative 3 over x raised to positive 4. And for our last example, it is always better to transform the radical into fractional exponent. So this is actually the same as x raised to 1/3 because cube root can be transformed into the fractional exponent 1/3. So, applying the rule for power, we have y is equal to 1/3 x raised to 1/3 minus 1. Simplifying this, we have 1/3 x raised to negative 2/3. And since we want the exponent to be positive, we are going to transform this into 1 over 3x raised to positive 2/3. Let's now have the derivative of a constant multiple. It says that if y is equal to kx raised to n, then y prime is equal to k multiplied by nx raised to n minus 1. Notice that we just get the derivative of this part, x raised to n, which is nx raised to n minus 1, and multiply it by k, which is our constant multiplier here. For our first example here, we have y prime is equal to 4 times the derivative of x raised to 5, which is 5x raised to 4. And simplifying, we get 20x raised to 4. Or you can simply think of this exponent being multiplied to the constant that is already there. 5 times 4 is 20, right? And then you just subtract 1 from the exponent. So for our example number 2, we have y prime equals, the exponent is negative 3, multiply it by negative 10, we have a positive 30. Then x raised to negative 3 minus 1. And then simplifying, we have 30, x raised to negative 4. And again, we want the exponent to be positive. So our final answer will be 30 over x raised to positive 4. For this next example, again, it is better to transform the radical into fractional exponent. So in this case, we write our y as negative 15 x raised to 1/2 because square root is transformed into the fractional exponent 1/2. Then applying the rule for constant multiple, we have y prime is equal to negative 15 times 1/2 is negative 15 halves. Then we have x raised to 1/2 minus 1. And simplifying this, we have negative 15 halves x raised to negative 1/2. And again, we want to make our exponent positive. So we have negative 15 over 2x raised to 1/2. And if we want to bring back the radical, then we can write our answer as negative 15 over 2 square root of x. Then for this next example, we can also rewrite this as y is equal to negative 5x raised to negative 6. If we transfer this x raised to 6 from denominator to the numerator, then the sign of its exponent changes. And now we can apply the rule for constant multiple. We have negative 6 multiplied by negative 5. That will be a positive 30. And then x raised to negative 6 minus 1. Simplifying, we have 30 x raised to negative 7, or we have 30 over x raised to positive 7. Let's now have the derivative rule for the sum and difference of functions. It says that if y is equal to f of x plus minus g of x, then y prime is equal to f prime of x plus minus g prime of x. In short, it just means that we just get the derivative of each of the terms in our function. So for our first example here, we have y prime is equal to the derivative of 3x raised to 7 minus the derivative of 7x. And what is the derivative of 3x raised to 7? If we apply the rule for constant multiple, then we have 7 times 3 is 21. X raised to 7 minus 1 is 6. Okay, and then minus the derivative of 7x, it's just a 7. Remember, we have here an invisible exponent 1, right? So applying the constant multiple, if you want that, 1 times 7 is still 7. While for the exponent of x, 1 minus 1 is a 0. And remember, anything raised to 0 is just equal to 1. So that means the derivative of 7x is just a 7. Now for our next example, y prime is equal to derivative of 8x cubed will be 24x squared, right? And then we have negative 5x squared. The derivative is negative 10x because 2 minus 1 is 1, so we don't put that anymore. Then we have minus 25, which is a constant. And the derivative of a constant is 0. So this is already our final answer for this example. This next example can be transformed into something that does not have the fraction term. Okay, so we can have this as y is equal to negative 6x raised to 4. We will transfer this x squared from denominator to the numerator. We just change the exponent sign. So, plus 5x raised to negative 2. Then, minus 3x. It is easier to differentiate function in this format. So, applying the rule for differentiation, we have y prime equals 4 times negative 6, that's negative 24. And then x raised to 3. And then we have negative 2 times 5 is negative 10. Then x raised to negative 2 minus 1 is negative 3. Then we have minus 3x. The derivative is just a minus 3. And then simplifying this, if we don't want, of course, the negative exponent, then we have negative 24x cubed minus 10 over x raised to, now it's positive 3 because we transferred it from the numerator to denominator. And then minus 3. For our last example in this video, we have y is equal to square root of x plus 2/3, so 4th root of x cubed. It might seem a little complicated at first, but we would like to, of course, transform it into a version that is easier to differentiate. And that is by transforming the radicals again into fractional exponents. Therefore, we have y is equal to x raised to 1/2 plus 2/3 x raised to, how do we transform this? So, the index 4 becomes the denominator of the fractional exponent, while the exponent of the radical becomes the numerator of the fractional exponent. Hence, we have x raised to 3/4. Now, it's easier to differentiate, right? So, applying the rules, we have y prime equals 1/2 x raised to 1/2 less 1. Let's do this step by step. Plus 2/3 multiplied by, we bring down the 3/4 as multiplier. And then x raised to 3/4 less 1. Then simplifying, we have equals 1/2 x raised to negative 1/2 plus, so what is 2/3 times 3/4? So as you can see, you can just cancel this. And then 2/4 is just a 1/2. So we only have 1/2 left. So 1/2. And then x raised to 3/4 minus 1 is negative 1/4. And then simplifying this further, we have 1 over 2x raised to 1/2. We made the exponent positive by transferring x raised to negative 1/2 to the denominator. And then plus, we'll do the same to this next term. 1 over 2x raised to positive 1/4. And if we want to bring back the radicals, we can write this as 1 over 2 square root of x plus 1 over 2 4th root of x. So learners, what would you like to learn next? Comment below.